Hello students, this is Miss Dalton and today's video is on normal distribution. When we talk about normal distribution, we're talking about another name for it is called a bell curve. So it'd be this one right here where it's symmetrical on both sides, okay? Like I said, we also call this a bell curve, and it's where the data is symmetrically distributed around the mean. Okay, so here is the mean, which is the average. Okay, we also have what's called a negatively skewed data. And I think of that as when, like, we call this the tail. When the tail is longer on the negative side, then that's going to be skewed in the negative direction. It's also called a left skew. You can also have the tail, sorry, let me change that. You can have the tail be longer on the right side. And this is when it would be positively skewed. Okay, so if the tail is longer on the right side, on the positive side, then it can be considered positively skewed, or we also call that right skew. And so this is when the mean is closer to the left side, but you've got some data that are just trailing over there on that positive side. We can also have data that are kind of centered around certain parts, and if there are two parts where the data is kind of congregated, bi means two, and so this is considered a bimodal graph. Okay, the main thing that we're going to talk about in this section is what's called standard deviation. Standard deviation is just a number used to tell how measurements for a group are spread out from the average mean. A low standard deviation means that most of the numbers are close to the average. A high standard deviation means that the numbers are more spread out. And so what you're going to see is you're going to see this normal curve where it gives you a mean value. Let's say the mean is equal to 10, and it might say that the standard deviation is equal to, let's say, 3. Well, that means that from the mean, we have what's called these standard deviations. So this would be 1 standard deviation, this would be 2 standard deviation, this would be 3 standard deviation. But to get those amounts of what that is right there, on the right side, you just add 3. So this would be at 13. 2 standard deviations would be adding 3 twice, and so that would be 16. And then 3 standard deviation would be adding 3 times, so this would be at 19. Now if I go in the backwards direction from the mean, this would be minus 1 standard deviation. So to get that, I'm going to subtract 3 from that mean value, so this is at 7. Then if I go 2 standard deviations backwards, I'm going to subtract 3 again, and so that's going to be at 4. Okay, so we've got these values that are at each of those standard deviations. If I go 1 more, that would be back 3 standard deviations. I'd subtract 3 again, so this would be at 1. And so this is how we're going to set up this graph in the examples going forward. Okay, this is probably the most used picture that you're going to use from this section. And this is dividing up the standard deviations, but it's also telling you how much of the data you're going to find in there. And this is what we call the 68, 95, 99.7 rule. Okay, and what that means is between 1 standard deviation of each side. So here we've got our standard deviation -1 all the way up to +1. 68% of my data is going to fall within those standard deviations. That means that all of, I've got 68% of my data that's going to be somewhere inside here. Now we could go a step further, and if that's 68%, then each of these half sections represent 34%, because we would just take that 68% and divide it by 2, so each one of these sections is 34%. Okay, now if we go two standard deviations, it's going to represent 95% of the data. So you can see that right here, 95% of the data is going to fall between these two standard deviations. Well, we already know that 68% is here. So if I subtract 95 minus 68, that's going to give you what, 27? And then if I divide that by 2, that's going to give you 13.5% for each of these sections. So right here, together, these two sections have to make up 27% of the data because I just subtracted 95 minus 68, and so the leftover is 27, but I have half on each side, so this is going to be 13.5%, and this is going to be 13.5%. So anything that falls between 1 and 2 standard deviations is going to be 13.5% of the data. Now if I go and I look at between 3 standard deviations, that's going to be 99.7. So all of this data represents almost all of the data at 99.7%. Well, let's figure out what each of these sections are. So this section right here, let's figure out what that is, and let's figure out what this is right here. To do that, we're going to have to take 99.7 and subtract 95. That gives me 4.7% of the data that needs to go here and here. Well, I'm going to divide that by 2, and I get 2.35. So I'm going to change the color of that so you can see that better. 2.35% is right here, and another 2.35% is right here. Okay, now we agree that 100% of our data should be represented there. So to figure out what's in this last little bit right here and right here, we're going to take that 99.7, we're going to subtract it from 100%, and that means we have 0.3% left for those two pieces right here. If I divide that by 2, then that's only 0.15%. So I have 0.15 here, and I have 0.15 here. Now this is going to be the most used picture because this represents all of the percents for each of these sections. So we're going to use this going forward. All right, I've got 2 examples here that represent the type of examples that you're going to see on your test. Okay, this one right here says the speeds of cars on a highway have a mean of 65 miles per hour with a standard deviation of 4 miles per hour. So go ahead and fill in your bell curve. The mean is 65, so that goes right here. Now let's fill in, we've got a standard deviation of 4 miles per hour. That means to get to my next standard deviation, I'm going to have to add 4. So right here, this is going to be 69. So I'm going to circle these numbers so that we can see what they are. Then I would add 4 again to get to the second standard deviation, and so that's going to be 73 miles per hour. Then I would add 4 again and get 77 miles per hour at the 3 standard deviation mark. If I go backwards, so now I'm going backwards 1 standard deviation, so I'm going to subtract 4. This would be 61. Go back another one, subtract 4. 57. Go back another one, subtract 4, so this would be 53 miles per hour. Now let's go ahead and answer the question. Now the other thing I want you to think about is where are these percents located? Okay, so if I cover this up and look at my percents, let's remember that as we're working forward, okay? So it says 99.7% of people are driving between what? Well, if you look at this graph, right, 99.7% is between the 3 standard deviations. So if I look at where the 3 standard deviations are, it's right here, and right here. So that means that they're traveling between 53 miles per hour and 77 miles per hour. Okay? All right. What percent of drivers are driving between 61 and 69? So now 61 is here, 69 is here. That's between one standard deviation, and if you remember, one standard deviation is 68% of the data. So that's going to be our percent. Okay, what percent of drivers are driving over 65 miles per hour? Well, 65 miles per hour is here. That's going to be everything on this side. Well, 65 is right in the middle, so that should be 50%. 50% on the right side of the mean, 50% on the left side of the mean, should be 65. Okay, and then 95% of people are driving between what? Well, if we go back here and we look at 95% of the data has to fall between two deviations. So if I look at the two standard deviations, they're right here. Let's go back and change that. Let's make that a highlighter. Here and here. So it would be between 57 and 73 miles per hour. So fill in your graph first, and then you'll be able to answer these questions a lot better. All right, I did these two examples kind of in a backwards order, but that's okay. Now we're going to do example 1. It says the mean life of a tire is 40,000 miles. So fill that in as your mean. So that's the very top number, 40,000 miles. And it says the standard deviation is 10,000 miles. So if I go this way, I'm going to add 10,000. So this would be 50,000. Keep adding 10,000. This should be 60,000. And then 70,000. If I subtract 10,000, this will be 30,000. This will be 20,000. And this will be 10,000. Okay, what percent of tires last between 30,000 and 50,000? So 30,000 here, 50,000's there. That's going to be your first rule, which is the 68%. What percent of tires last between 30 and 40? So 30 and 40 is just going to be this section right here. Okay, so that's going to be that 34%. It's half of 68%. Okay, what percent of tires last over 70,000 miles? So the over 70,000 is this piece right here. And if you remember, after the third standard deviation, that was 0.15% if you look at that picture down there at the bottom. So it should be 0.15%. And then what percent of tires last longer than 60,000? So 60,000 is here, so it's going to be everything over here. So that's going to be the 0.15, but it's also the 2.35. So if I add those together, that comes out to be 2.5%. Okay, hopefully this was helpful for you. Just please let me know if you have any questions.